All right. So thank you all for coming. I think everybody here knows me, but if not, I'm Hillary. And this is Evan and Chris. And we're the people who put hackNY together. I'm going to keep it pretty brief so you can hear from the students because they're the cool people anyway. But hackNY, we've had these 12 fellows working at various awesome startups around New York City for the last 10 weeks. This is actually the last day, their last day of work, and they're getting kicked out of housing soon. So we're hoping to sum it up by sort of celebrating what they've accomplished this summer. So what you're going to see here are demos of the projects they've worked on during their internships at different companies. All right, so first up is going to be Tal. Tal is a student here at NYU, and he spent the summer at Aviary.
Hi everybody, thanks for coming. I'm Tal Safran. I worked at Aviary over the summer, and I'm going to demo a project I worked on called Chicken Farm. So Aviary, for those of you not familiar, is a suite of free online tools for digital for creation, remixing, and sharing of online content. We also have a few single-serving effects for Facebook, and that's what Aviary is about. When I came in, they wanted to help me extend their service from just a point-and-click graphical user interface to something more like a web service or an API. So that's what Chicken Farm is. So you can go to Chicken Farm. Cool. So when I was building this thing, I started out by just building a sandbox and seeing what I could do with just plain old open source image editing tools. So a lot of things you do with graphical user interface graphic editors, you can probably automate, and it would probably be a better experience not to have to open up the image editor. Resizing is something really common. So instead of launching Photoshop or an Aviary tool, you can just call this API and resize an image, and it'll do that. You can also do some effects like you can edit the color saturation or corrections, if you want to sharpen the image. This one takes a second. All right, we'll do something else. Removing noise, and there are a few effects like you can do a sepia tone, oil painting, a really cheesy Polaroid effect, etc., etc. So this was just the sandbox, and then we said, sorry, I'm looking at my notes. We said, let's make this an API that any developer or person with a photo on the internet can use. So here's a picture I took a few weeks ago. bit.ly/cupcake guy. Oh, cool. All right, yeah. Exactly, yeah. So a few weeks ago was Bitly's birthday. We were all invited. We went over there. They made these cupcakes shaped like the Bitly logo. And I took this picture with my phone, and I thought the color was a little bit off. So using Chicken Farm, I could just edit it and correct it on the spot online. So you can do chickenfarm.aviary.com. and then put in the command I want, which in this case, let's say I want to reduce the color saturation by a little bit, and it'll do that on the spot. This projector's not that great, but let's say I wanted, you could chain commands too, so if I wanted to, let's say, correct the contrast, I can do auto contrast, or resize it, or do something like face detection. This could be used for a lot of things like smart cropping or smart thumbnailing, or if you want to do these wacky little effects where instead of a person's face, it's like Scooby-Doo or something. You could do that because you know the coordinates of the face. So this is cool, and this is for if you have an image online or you're a developer and you want to use this to automatically edit your pictures, and this is totally savable. It retains the MIME type and everything. So if your picture's not online, a really cool feature we thought of was emailing. So if I took a picture on my phone and I wanted to just send it to Chicken Farm, I could attach the image, put the instructions in the subject line, and it'll send me back the picture corrected. I was playing around with this today, and I actually ran into some issues, so I won't be showing it to you guys, but it's pretty cool. That's all I have. Thank you.
That was awesome, and I hope you all respect how hard it is to do a live demo. Next up is going to be Chris. Chris is a student at Princeton, and he worked this summer at Tengen.
Good? Yeah, perfect. Okay, so I'm Chris. I'm a Princeton University student. I'm going to my junior year. This summer I worked at Tengen, and what they do is they work on an open source project called MamaDB. It's a database. It's NoSQL. It's scalable, high performance, open source, and document oriented. So just to show you what document oriented is, you'd store JSON-like objects. They have a format called BSON, and it's really natural, really easy to just store information in their database. So you can store strings in these and access them by keys. You can store ints, more BSON objects, and arrays. So the way you work with the Mongo server is you use a client driver, and we have plenty of different languages. And I was assigned to work on a certain piece or some certain functionality of the C driver. So now with MongoDB, sometimes you want to store files. And MongoDB allows you to store binary data, but each document has a cap of 4 megabytes. So, sometimes you want to store files bigger than that. Well, we offer GridFS, which allows you to transparently store files into MongoDB. And what that does is, behind the scenes, it breaks down the files, stores them in the database, and when you want your file, you just query for it, and it will put it all back together and give it to you. So the C driver, when I came in, didn't have this functionality, and I created an API and worked on it and got it all working. So this is the API. I think it's cut off a little bit. This is the .h, all in C, without any comments. But yeah, so unfortunately, it's not that interesting to demo, and it's very, very hard to demo it on someone else's computer without installing Mongo and everything. But it works. So, it's easy. It stores files in Mongo, and you can retrieve files. That's great. And if you don't believe me, you can go on GitHub yourself and download my source code, compile it, and it should work. So this led into the next project, which is working with Nginx. Nginx is a super fast, open source, Russian-made web server written in pure C. Why it's Russian-made is very important is because all the development documentation is either non-existent or in Russian. So that's fun. So, someone came up with the idea that, okay, let's harness Nginx's power of serving files really quickly with Mongo, and we'll be able to serve GridFS files very, very quickly. So when I came in, they had this working a little bit. They were using their C++ driver, and it basically worked. If you had a file named foo, you could query it by doing myserver.com/foo, and you get the file back, and that would be a file that was stored in Mongo. So when I was done with it, I was able to change a bunch of things around. Most importantly, I took out all the C++ and put in my C that I worked on previously, and that made it much nicer to build and use, and that's great. I also made it able to access by ID instead of file name, but still keeping the file name functionality there. Just because, you know, who's to say you might have a file name that's, you might have more than one of the same file name or whatever. And so, you know, I made each Nginx worker process have its own connection to Mongo to eliminate excessive blocking by the processes. And I added authentication, auto reconnect, and I pretty much made it faster. So just an example of how you'd access these files, very basic. You can customize the URL to anything you want. I just said file name ID, int ID, just to make it easy to understand what's going on. And also, you can check it out on GitHub as well. The thing is, it's still not that fast. It's never going to be as fast as serving static files. But there are many advantages to keeping all your data and files in Mongo. And some of that is organizing all your files by unique object IDs, sharding, and replication. Currently, I'm working on an asynchronous version of the Mongo C driver. So I'd have to rewrite the entire Mongo C driver. And I'm working on that, and it's tough, but that's my next thing. And that's it. Thank you.
I did notice that you replaced me with a small text file. Okay, so next up is Jacob. Jacob's from NYU and has been working this summer at Parsley.
Fancy logo, look at that. So yeah, you know my name, you know I work for already. This is the hackNY demo of Parsley. What is the Parsley API? Well, it's this. Let me explain what Parsley is. Parsley does article recommendation for news websites. So you're reading an article, you read a bunch of articles, it builds up a profile of the sort of articles you're reading, and sort of tries to determine from that what you like. It does this content analysis on the text and then recommends new articles, either based on the article you're reading or it builds up this personal profile of the sort of things you like and recommends articles based on that. The API allows you to do calls based on topics or interests, basic things like that, and it will give you this nice big JSON file of all the results. So that's that, and how is it built? Well, we've got these things. So aside from just the API, there is this nice little widget that is meant to be put into different pages on the actual news websites that are using this, and these have each of the articles, well, you'll see later. There is also the JavaScript bindings, Python bindings, all very nice. And the stack is all based on Stoller, Mongo, and then a Postgres SQL database. So what did I do? Well, we needed thumbnails because that looks very pretty if you can actually see something related to the articles. So I wrote a little thing that would go into each article, scrape out the image that whatever the news site is, they put up images next to an article. Take that out, make a thumbnail, upload it to the cloud server, and then stick it in the widget. So that's nice. Well, let me actually show you the live demo. So you can see this getparsley.com for older people who don't understand that .ly is actually a thing you put in. So this is a sort of mock-up of the page you would have. I mean, none of this really, but this widget you can see would follow the user on the page. So we can kind of imagine we're clicking through. This URL here represents the page where, not really on, but kind of virtually on. Let me log a visit to that page. So, I'm reading articles. Let's see. I want to learn about usual loans. Okay, sure. Ooh, lawmakers. So I'm logging all these visits and it's building up this profile of the sort of things I like. And we can see that profile. Click here, interest profile. And, that's not very much. But you can see you have different topics. These are categories provided by actually the Wall Street Journal. But these ones are fully built out of the text analysis of the articles that I chose to log. So let me log a few. I'll just log this one a lot. Let's see. So there, got some more now. So these are the articles that are being recommended based on this particular article, and then we have also the personalized recommendations based on the profile that I just built. So aside from all that, the main thing that I worked on was, let's see, where did it go now? So this is fun. The thing's actually running my little notebook there, but I tunneled it through this service, localtunnel.com. So this is, I like this. What was this? So the most visible thing that I'd been working on that would make for a nice demo is this panel, which is not running in this browser. That's unfortunate. Well, I'll just show you the screenshot. That's not as fun. Wait, where did this PDF viewer go? Preview. That's a weird logo for that. So this is kind of what it looks like. Too bad I can't click through it, but basically you're given this API Explorer. You're able to enter API calls there. It'll construct the whole URL. This tab, which will show you the JSON, this tab here will give you this nice grid of the different things. There's a few other things. There's some analytics. We'll show you the articles, the vids that have been logged through your key. This is meant to be used for any different news site. You know, anybody could just sign up and they can see what their users are doing specific to their thing. This doesn't show it, but there would be put here an API key specific to, you know, it would be the Wall Street Journal, or the Examiner, whoever it is that you're looking at right now. Yeah, that's it really. So I'm clapping.
All right, so our next speaker is actually going to be phoning it in. We have a video presentation from Nolan Filter, who is an NYU student and was working BuzzFeed. Here we go.
Hello all, Nolan Filter here. I spent the summer interning at Business Insider, a news startup that aggregates articles and posts original content relevant to technology, financing, and startups. They recently went through another round and raised $3 million, so it's an exciting time to be here.
Just look at how happy they all are. This was in the newsroom where they had televisions. I was in intern alley, where we could hear all the fun but not actively participate in it. But that's okay, because I was streaming the World Cup on my computer anyway. BI has a growing staff of 30+ employees, which includes journalists, salespeople, and computer scientists. This summer, they've also brought in a fleet of paid interns, mostly editorial, to help generate new content. I have the distinction of being the first ever tech intern. Oh, I wasn't that bad. Anyway, my major project here at BI was to create the video gallery page that you see around me. Through this project, I had the wonderful opportunity of becoming completely frustrated with HTML and CSS. Also, the different ways that different browsers render JavaScript, for some reason. But I also had a little bit of time to tinker around, and ultimately, I came up with something that I'm pretty proud of. And look, it flashes too! It has different tabs that relate to the different verticals of the website, as well as lists of the most recently uploaded videos and the most popular from the last month. This is created using JavaScript and HTML. I've read just about enough out of you. Display the title like you're supposed to. Eh? Eh? I created you! Much better. This is how I change the player to a different video. The video channels are automatically generated by making API calls to the website that hosts our videos, Uyala.com. Uyala has a number of APIs set up to help fully customize a video experience, and I'm pretty sure I've fully explored all of them in my quest to make a cross-browser compatible player.
Finally, something we can agree on. The APIs are called using PHP. This is how I format the XML that's returned by the API call into the HTML that populates the video channels. This is passed as a string from the PHP page into the HTML page. Since the channels do not change on a minute-by-minute basis, but rather when new videos are uploaded to Uyala, I set up 2 layers of caching to help alleviate the stress on our servers. The first is on Uyala's server, which refreshes every 6 hours. The second is on our server, which refreshes every 3 hours. This is the code for the widgets I made, which I have affectionately dubbed Vidja. The code largely resembles that of the video player, and calls Uyala's API in the same way. It also employs similar HTML and JavaScript. I also created a few widgets to link back to the video gallery page. They automatically populate with the most recently added videos in each of the 6 channels and link back to the video page to play the proper video. This is achieved by passing the unique video code and title parameters through the URL. Here's one of the widgets. It has lots of tabs, so you know it's good. You can click on any of the videos, and it'll open up a new page that links you to the video you want to watch. Nifty, huh? Whoa, metaphysical. I hope you enjoyed my presentation, and please look for my video player to go live on businessinsider.com in the next few weeks.
So we're all really sad Nolan couldn't make it tonight, but I think he represented himself and his work pretty well. Next up, Stewart, who worked this summer. Where did you work this summer?
I worked at Newton.
At Newton, of course. And there we go.
Okay. Hi, I'm Stewart Parton. I just graduated from Columbia University with an undergraduate degree in computer science, and this summer I worked at Newton. That's Knewton. Newton is a test prep agency running out of Union Square. We currently have online courses for the SAT, LSAT, and GMAT. And what's core to the Newton method is our adaptive learning system. Now, every piece of content that a student may see, such as a sample question, each individual answer in these questions, as well as the educational content within the site, these can be tagged with concepts. Concepts can be broad, like algebra or grammar, or specific, like inequalities with variables in the denominator. Now, Newton can track a student's performance in these tagged questions and use that in order to determine what concepts a student might have mastered and which concepts a student might need more work on, and serve the appropriate content. Now, a bit of stats. Newton has over 2,500 concepts, 16,000 questions, and 72,000 answers. And as these numbers grow, it's important to have a way to find these pieces of tagged content quickly and easily, which brings me to one of the projects that I worked on at Newton, Tag Search. Tag Search is just a simple way to select a number of concepts and find all of the pieces of content that have been tagged with that concept. So let me demo some examples here. Okay, so say you're making a GMAT quiz and you want to figure out what questions that are in the database are tagged with combinatorics or statistics questions. So over here you would switch to GMAT, you would see the concepts in this concept viewer here. The concept viewer is a widget created by Newton's own Christopher Tang. Drill down to the concepts you want, add them to the search, combinatorics and statistics, and then simply search. Here, see all of the questions. From here you can see the individual questions, edit them if you have the privileges, and also see the tags which relate to the concepts you've chosen. See all of the questions, all of the answers, and all of the pieces of content which explain these concepts. And this can also handle much larger queries if you wanted to, say, see every single math question in our database. A simple search. Now I guess talk a bit about the tech behind it. Just simple, for the front end, simple HTML, JavaScript with jQuery and embedded Ruby. For the back end, used Ruby on Rails, interfacing with the MySQL database. And pretty much it.
All right, so we're halfway through, so everybody wants to take a deep breath and stretch a little bit. That was awesome. Thank you. So next up is Tang Shao. She's worked at Buzz this summer. Nice shirt.
Hello everyone, I'm Tang Shao from NYU. During the last 10 weeks, I was working for Buzz, BUZZD, and Buzz.com. What Buzz does is Buzz try to aggregate all social medias like Facebook, Twitter, Guala, Foursquare, Loops, Yelp, etc. Those social media provide checking service, and we want to get all those check-ins and make sense of those check-ins. If you download an iPhone app or Android app from your cell phone, and then you can use that to see what's going on around you, like what's the most popular bar or popular restaurant. And for business owner, you can use the tool to see how many times people checking your venue and who are they. And you can find them on Twitter or those social media. What I was working on for Buzz is the indexer. We use indexer to make a match. We try to find place name in a sentence or in a tweet. Indexer is the software that extracts significant words in a text, storing the document in a searchable database. I'm going to talk about the two things I have made. One is minimum context match, the other is indexer acceleration. The first one. Before I came to Buzz, they have several algorithms to match place name. For example, after preposition, add to from Times Square. And sometimes we do not need prepositions because the venue name is unique enough, like American Museum of Natural History. And sometimes we don't want to match like North if there's a place name. We don't want to match North Little Rock. It's another place name, though it shares the word North. And sometimes we use abbreviation. For example, MoMA stands for Museum of Modern Art. Instead of having so many algorithms to fit each case, I just want to simplify them and use only one algorithm. I use positive context and negative context. Instead of have several algorithms, we store the possible positive context in the database, and then every time we just get that content out of the database and match them. The meaning of negative context is that, for example, David Matthew Band's Central Park concert CD is actually the CD, not the Central Park. For example, if someone tweets on Twitter, I'm at Central Park listening to David Matthew Band's Central Park concert CD, the first step is to remove the negative context from the tweet. So it will be I'm at Central Park listening true, and then we match the positive context at Central Park. And this is the dashboard for the matching result. Okay. The next part, indexer acceleration. We have two problems. The first one is if you match a tweet with venues across the US. We have so many venues, thousands of venues. If we match them individually, it will take a long time. The other things, we may have some venues share the same name, like Starbucks, McDonald's, Dunkin' Donuts. We don't want to match a McDonald's in New York to the one in Florida. The solution is we only match one tweet with the venues within a bounding box, within the area. I'll show you. This is the old algorithm. It will go through every venue across the nation and then find the correct one. The new algorithm is, it will first use the bounding box, find the venues within the bounding box, and then find the correct one. I just took the data structure class from Evan Koth, and then I used some data structure knowledge to solve the problem. He's here. Okay. The idea is I want to use memory in exchange of speed, and I use a special tree structure. The property of the tree structure is that parent knows what their child knows. First, I will show how to put venue data. For example, I worked for Buzz HQ, it's Broadway A33, and it's lat long there. And then we used formula to get a formalized value of this lat long. And then we use this normalized lat long as a pointer, some kind of pointer to go to the memory. For this, you can see this as the data structure in the memory. You can imagine this is the thing in memory. And if we want to put a star sign in 122, we will go 122. And then this is the actual data layer. We store star in those three places. And if we want to use 131 to store $, we store like this. And if we want to store letter A to I from 111 to 133, we store like, after we store that, we like this. So like the one on the top is the parents, so it knows what its children know. And then this process will accelerate the when we want to get data, it will accelerate a lot. For example, we want to get value within the bounding box. It's from between the latitudes 40 and 41, longitude -74 to -73. We will first find the normalized value of this bounding box. Then I will use a demo to show you. For example, now we want to get data between 123 and 213. The old way is we look at each child, the last level, the lower level. We will try to see 111, and it's smaller than the lower bound 123, so it's not correct. 113 is not correct, and that until we find 123, it's correct. And use the similar logic, we can find 132, 133, 211, 212, and then we find 213. All this, now we get the data we want between 123 and 213. That's E-buzzed. But the new way is that we can directly get the data. First, we find out the lower bound, 1, 2, 3, and then we find the upper bound, 2, 1, 3. And then we just find as much parent node as we can between the two ends. So we find the similar data, find the same data, E, B, U, C, C, D. Another extreme case can show how much faster. For example, we want to get data 001 and 30. Actually, it means all data. We want to get all data. The old way is we get data one by one. I, L, I, K, E, B, U, C, C, D, dot, C, O. M. So C is very slow. And then the new way is we get as the new way is we just get 0, 0, 1. 3, 0. As transparent as we can, so it's very fast. I like this.com. Okay. And I will visualize the process happening in the memory. So we first get the values between two latitudes, and then we get the values between two longitudes, and then we find the intersection of those values. Then we can find the bounding box. Then we use this algorithm to match. It's much faster. Actually, if the task takes 150 minutes to finish, the new algorithm will only take 3 minutes. So it's 50 times faster. And actually, this algorithm is only compatible with tweets with geographical information. If we don't have that, we will run into problems. But David, my mentor at Bus HQ, he's a great architecture in computer systems. I learned a lot from him. And then he just invented a new algorithm which can use a map structure to finish all this very fast. Actually, if we have enough memory, all this indexing can finish in a second. Okay, thanks to all of us at hackNY.
I think Tang Shao will be teaching data structures next year. Next up is Max. Max worked this summer at Designer Pages.
Cool. So I'm Max Stoller. I'll be a junior at NYU studying computer science, and I worked at a startup called Designer Pages. Designer Pages is a social application for interior designers and architects to find and share products. And the biggest industry conference is called NeoCon, and Designer Pages partnered with NeoCon and built all of their applications. So I spent about half of the summer building their CRM and building all the applications that kind of drive the conference. And I thought that the most interesting application that we built was kind of like a real-time dashboard. So I have pictures of what it looked like at the conference. So this is just a picture of what it looked like at the conference. Basically, if you go to a conference, a lot of times they'll have really big LCD screens of some sort of information. And at a lot of conferences, this information isn't real time. It's really just like a PowerPoint that is set to auto scroll or something. It's not that impressive. So what we built was a system that would aggregate real-time conversation from Twitter and then do some semi-intelligent analysis of the conversation and come up with displays that would be useful to the 40,000 attendees. So something that it does is it'll aggregate all these tweets that are talking about NeoCon in real time, and then it will determine trending topics. So here, for some reason, elevators is a trending topic. You can guess that maybe an elevator broke down and everyone's tweeting, I'm stuck in the elevator, or don't use that elevator. Bathrooms is tweeting. Could potentially be useful. Someone's asking where the bathroom is on Twitter. Designer Pages, chair, lighting, kind of interesting. So this is just a video of it working in the office before NeoCon. This is all canned data, but you can see there's some cool HTML5 and CSS3 trickery going on here. Not much else to show for that. Right. So we have this up. The app was internally called Tweetball. So obviously NeoCon isn't going on right now, and we don't have any real-time data to display, but we have some canned data just so you can get an idea of what's going on. So if someone is at a booth and they see a product they really like, they can take a picture of it, tweet it. We'll find that tweet, we'll find that twit pic, we'll download it, and we'll display it in real time. We will select certain tweets manually that we want to display. We'll show those tweets. If everyone's talking about a certain topic, we'll display that topic. If everyone's talking about a certain product, which is kind of interesting, we'll display that product. And then finally, we do some analysis to try and determine the mood of the audience. So if everyone's excited or happy or any other sort of adjective, we will figure it out and then display tweets, with that mood. So I guess the technical side of this is that this is Ruby, Ruby on Rails, and Mongo powered. We have a rake test that scours the web for all these tweets and twit pics and stores it all in Mongo. And in real time, we do some analysis and display it with HTML5 and CSS3. So that's what I got. Thanks.
Thanks, that's really cool. So our next speaker also couldn't be here in person tonight, but Julie Dinnerman worked this summer at Aprisi with Liz and Gif, who are here. Would you guys wave? So if you have questions, you can ask them after. She also prepared a video, so you'll be hearing from her about what she did.
Hi, I'm Julie Dinnerman. I'm the hackNY Work Fellow working at Aprisi.com. Currently, I'm studying electrical engineering at Columbia University, going into my senior year. This summer at Aprisi, I learned a new programming language and framework called Ruby on Rails. Let me tell you a little bit about Aprisi. Aprisi is for busy women who enjoy shopping for fun, but don't have the time to sift through everything on the internet to find stuff they'll like, especially stuff from smaller retailers. So what Aprisi does is gives them product recommendations, kind of like Pandora, but for shopping, so they can more easily find things that they might like. So the Aprisi strategy mixes machine learning personalization with curation and simple design. I worked on a bunch of features this summer, but I want to show you the search that I implemented, which currently is only a feature for admins, but will be integrated into the user views shortly. So in Rails, there is a three-part architecture. There are models, views, and controllers. The models are like classes that contain contain attributes, and they contain methods that are specific to those classes, and they usually correspond to a table in the database. Then there are the views, which create the visual pages that the user will see. Then there are the controllers that have methods that enable the models and the views and the information from the database to interact with each other. So for my search tool, I used Sunspot, which is an open source tool supported by Stoller and Lucene. And it provides search tools for use with Ruby code. So I placed some search code I put a search method into the admin controller here. You can see that I used some methods from the Sunspot API, which is right here. So I used sunspot.newSearch, built a new search, searching the rec item table, and then we pass a search parameter into the search and build it here, and then we execute the search and pass the results to @recItems. The way that we pass the parameter into the search is we get it from a text field in the view, and then the search results are displayed in this view page right here, and we display the store name and the price and an image for the search results. And this iterates through all the results in @recItems, this for loop. So let me show you how it works. Let's search for jewelry. We'll see what comes up. So here we should get all 8 of the jewelry items in the database, and here it comes up like this. It worked. And also another cool thing about Aprizi is that you can search for, since items are categorized in a variety of different ways by their different attributes, you can search for different specific attributes of something you might be looking for. So let's look for eco-friendly stuff and see what comes up. So we see that there are eco-friendly things that are in the database that we can easily pull by using the search. Now I just want to say thank you to Chris, Evan, and Hillary, who were great leaders for the Hack New York program, and also thank you to all the Hack New York fellows, and to Gif and Liz, the Aprizi founders, who really taught me a lot and gave me a great summer. Thanks.
So our penultimate speaker tonight is Anil, who spent the summer at OkCupid playing with lots of data.
All right, so I'm Anil. I'm a graduate student at Columbia in applied math. And the last 2 months, I was at OkCupid trying to improve their love machine. All right, so for those of you who haven't heard of OkCupid, you should think of it as the Google of online dating. So when you first go in, so the way that OkCupid matches people is by asking you a bunch of questions. An example page would be, I don't know if you can read from that axis, how important are your political beliefs? You have to answer the question how you would like to answer. Then there's a choice of how you would like your ideal match to answer, which could be multiple checkboxes. Then how important you think the answer is. And the way they compute the score is you have some scoring for the importance for each question. And they want to know how, let's say you have users A and B, the goal is to find out how much user A satisfies user B. So for instance, in this case, if another user B comes and answers this question a little important, or say not important at all, you answered something that user A wanted you to answer. So that's sort of a match. And the importance assigned is very important, so you would get 50 points for that. And if you didn't answer, say if the user B didn't answer the last 2, then you'd get 0 for that. And then you do this over all common questions that user A and B have answered, find a geometric mean, and that would be a match. Now, when a new user goes on, they get pretty much the same ordering of questions. This ordering is updated once in a while, I think once every week or 2 weeks, but it's pretty much the same. And very often this database of questions may not be quite relevant for once a new user has answered 10 questions, you should be able to figure out if some questions are relevant to them or not relevant to them, or offensive to them or not. And there's no algorithm that does this currently. So for instance, you might get a question like this, which is probably not relevant for people who are not math nerds. Or a question like this, which, if you're not into drug use, you really think it's offensive. Or something as horrible as this, maybe. So the key goal would be to try and, I guess, the first goal would be to cluster users into groups, into some natural grouping that's there in the database of OkCupid users. And then find a question ordering that's sort of personalized for a user, and essentially also remove questions that are offensive, or if a user has answered a certain question, you should know that some other questions are irrelevant or redundant. Now, the thing that didn't work is actually very interesting. I didn't expect this at all. So all the users for OkCupid could be thought of as a network, and the edges in the network are the match percentages. So our first instinct was to go and cluster this network. Turns out either clustering a network is a really hard problem, but we didn't get any useful information out of it. So there were no useful clusters. You couldn't sort of discern any similarity among users in a cluster, in a sense. So what we did go and do was, so I won't be explaining any of these terms, but I just wanted to throw it in there in case you're interested and you want to come and ask me later. The idea would be to do clustering by thinking of the clusters as a bag of dice. So the dice are questions, and a die is biased if a question is answered in one way more often than another way. So you could think of each user as being drawn from a die. And then once you have the clusters, you would use an algorithm, the multi-class addables, to figure out within a very few number of questions which cluster does each user belong to. And now once you've put the user in that cluster, you then have a personalized ordering for that cluster. So a user will not see questions that come from another cluster. So the current order of ordering of questions, something like this. So for instance, in this ordering, you could see the ones colored in green seem to be reasonable. The one colored in red are really not useful, like how often do you brush your teeth? I don't know. Say questions in purple here seem to be redundant. So maybe if someone answered a certain way for this, you probably know how they're going to answer the next one, so you don't have to ask them, or vice versa. And what I did was to improve the question ordering and make it into a decision tree. So this, okay, I'm pretty sure you can't read those. Even I cannot read them, so I'm sure. Never mind. But for these are 6 questions that any user would first see. And for each question, depending on how you answered, the red circles would give you a certain weight. And once you get, you add up all the weights for that user, and then you can say they're in one class or another class depending on the size of the weight. And these questions have to do with politics, drugs, abortion, smoking, etc. And this actually does pretty well. If you know, so this is for a 3 clustering, and if you can assign users into a 3 cluster with about 70% or between 70 to 80% accuracy with just 6 questions. And this is to give you an idea of, so this is the histogram of, these are the 6 questions, the different colors of the 3 clusters. So you could see in the first question, the red cluster seems to answer no more often than yes. And blue. So there's sort of a difference. You can see that these questions could be used to construct a model to group users into clusters. So I guess the key step, the next key step would be to find out what is the right number of clusters. You don't want to say, oh, there are 10 different kinds of users on OkCupid. You would like to find out what's the natural clustering, and maybe even to try and make sense of what these clusters mean, hopefully. Then find the question ordering that's relevant to each cluster. So it could be, I'm not entirely sure what's more important here. If you notice, for each question, a user could assign how important the question is. So maybe for each cluster, you should need to give them questions that have high average importance. And then you don't want, once you put a user into a cluster, you don't want him to remain that cluster forever. Maybe his preferences change, or he understands himself better. So you'd like them to get questions from other clusters too, or get matches from people who are in other clusters as well. So you'd want soft membership or soft clustering. Yeah, so there's no app or demo. This is more math. But I think that's cool. All right, thanks.
Thanks. In this crowd, math is very cool. So last but not least, by any means, is Ian. He's a student at Rutgers and spent the summer with us at Bitly.
Cool. So my name's Ian. I spent the summer at Bitly, which is a BetaWorks company based out of the meatpacking district of Chelsea. So when I got to Bitly, they kind of gave me this question, what do we do when we want to share a bunch of links, right? So Bitly's really good at sharing one link, as you'll know on Twitter and everything. So, but like, what happens when you want to share, say, 5 links? It gets kind of weird, right? You got to make like maybe 2 tweets, remove all the context. If you're on IM, it's like 5 IMs or something, right? So it's just nuts. So we kind of came up with this idea of bit.ly bundles, right? So a page where you can enter 5 links or more, however many you want, and kind of give somebody the summary. So you can share this one page and give them kind of an idea of what all your links are about. So for simplicity's sake, imagine I'm a 13-year-old girl, right? And I want to share a bunch of links about Justin Bieber, as 13-year-old girls do. So I'll start off with the Bieber homepage, right? So I have my one link here. This is, oh my God, Justin Bieber. That's how 13-year-old girls type. I have a description, All right, so we have our one link, right? Simple little, not too much there. But then when we get to the more rich links, kind of like a Twitter stat. Oh man. A Twitter status, right? We get this kind of rich preview. So what we do is we try to crawl the web pages and find, like a way to represent the content of that page. And this kind of like rich little embed. And so from here you can go and you can, rename this like Justin Bieber at Burger King. In all caps. You can annotate it, it works for a lot of links. It works for, let's see. This is a good one. So you got this YouTube video. This is Justin Bieber on a Segway getting chased by a All right, so this is just a cool example too. So if I throw in a Wikipedia article, it's not just for videos, right? So I'll pull some cool rich text here. This is all powered by a service called Embedly. It's an API that you just send it a link and it sends you back whatever it can. So here we got this like rich text preview. So say, I want to throw this funny video up top, right? And go rearrange it, save it. If I don't like information, I can delete, Wikipedia. And from here, I can share, right, this one link. And when the user lands on this page, they kind of have a summary of every link, that I'm sharing in the list. It has the same kind of bit.ly stats. So we have, up on the top right, we have the number of clicks on the link that you send out, and then below on the number of clicks on the links that everyone has sent out, not just yours. With our new recommendation engine, we're going to try to suggest some similar bundles. So, these are just canned, obviously, but in the future, maybe it'd show you, InSync or whatever else 13-year-old girls like, and kind of provide a summary of where the links are coming from on the bottom. And again, just like the info page, we want to provide a summary of kind of social interaction, who tweeted about this page, friend feed, all that stuff, comments on the page. And yeah, that's bundles. Oh, and so yeah, so if you're hooked up to Twitter, it would just, click this and you'd be able to share it. Just like you can share links on bit.ly. Yep.
This is awesome. So I'd really like to thank all of the fellows for getting up and sharing their work from this summer with us, and also for letting us hang out with them all summer. This has been really super fun. So thanks, guys. I'd also like to thank, actually, if you could put your hand up if you're with a startup who hosted a hackNY fellow this summer. All right, thank you. Thanks a lot. For your mentorship and support. And we also would like to thank isoc-ny and the Kaufman Foundation for providing the funding that made this all possible. And I'd personally like to thank Chris and Evan, who are awesome and put in the time and thousands of email messages to make this possible. And I'd like to let you know about our hackathon, which will be October 9th and 10th. And we're going to use that to kick off next year's program. You're all invited. It'll be right here. And you can register now. All right, so we'll linger around here for a few minutes if you have questions for the fellows. But thank you all for coming, and hopefully we'll see you soon.
Thank you, Hillary.